Okay, so now we're going to be working on part C of the 6-4 notes. Look at me, you can see me without a mask, so there's one positive. We are going to go through the rest of these notes, and then we will use our Google Meets as a chance to get together Thursday or Friday, depending on your class, and make sure you check out your times and that you show up. I'll send you your invitations for all of that. And then we will go over questions, go through homework stuff. We'll just go through things where we can kind of interact. But I need you guys to have these notes viewed and in your notebook before you get there. All right, so part C, we're just sketching a graph. So keep in mind that number one, they're not going to be perfect. Yours could be a little bit different than someone else's. Number two, depending on what they give us, there might be multiple correct answers. As long as you meet all of the criteria, you'll be all right. There's not always just one right answer here. So on example one, we're trying to just sketch an odd degree function with zeros at -1, 0, and 4. So the first thing that I do is just make a graph space. Okay, and I don't need it to be super big. I just want to make sure that my x-axis has those values on it. Okay, so making sure. And notice they didn't give us anything about the y-axis. So I'm just putting some values here, but those don't really matter. Okay, we do know there are zeros at -1, 0, and 4, so we know it has to cross the axis, the x-axis at those points. So I'll go ahead and put those points. And also we know it has to be an odd degree. So because it's an odd degree, we know that the end arrows have to go opposite directions. So either the left side's going to be down and the right side's up, or vice versa. And the reality is this one could actually work either way. So if you start down, up, that's one way, or you could start going from up here, go down, up, down. That would be two different ways you could give this answer. They'd both be the same. So if I start here at the bottom, work up, come back down, go back up, I know, okay, my end arrows need to go opposite directions. It's simple as that. Okay, or you could have this basically flipped upside down. That would be also acceptable, where this arrow would be up here and this arrow would be down here, and all the hills and valleys would switch. All right, that one's done. Okay, if you need to, if you don't have this done, pause here. Okay, and then you might want to pause and copy down example 2, which says a 4-degree function with zeros at -2 and 2, and relative max at x equals 0 and x equals 5. Okay, so again, I'm just going to sketch my graph. Okay, I just need to get all the way up to 5 I can see on the x-axis, at least. Okay, so now on this one, it's a 4-degree function. So that means it's even. So both arrows either have to point up or down. And I also know that if it's a 4-degree function, that the maximum values of hills and valleys we can have is 3, because it's always going to be one less than the degree, the maximum, like the relative max and relative min. That's maximum. They don't even have to have that many, but they could have up to that many, up to 3 hills and valleys. That's it. Okay, if it's a 4-degree function. All right, I know it doesn't say that in the notes, but it's kind of implied based on that last part where it says that's the smallest possible degree of the function is the number of relative max and mins. So now I know it has zeros at -2 and 2, so I'm going to put points there. And I know it has a relative max at x equals 0 and at 5, which means that the top of a hill has to happen when x is 0 and when x is 5. It doesn't have to be on the x-axis. It just has to be where the top of the hill happens. So I know that either both arrows have to end up or down. So I'm thinking, though, that if I need to have a maximum at 0, I'm gonna start down and then go upwards to get there. That's the only way that's gonna happen. So I'm gonna start here, I'm gonna go up somewhere and then back down, okay? I'm not done, but I'm gonna make this arrow here, which means I need my other arrow to do the same thing. Okay, and so now I need to have another, I need to get another max at 5. So perhaps I would do something like this, where it comes down here, goes back up, and then goes back down. I was just trying to avoid crossing the x-axis again, so I wouldn't get a 0 at any other place. I guess there could be a 0 at another place, but since it doesn't say it, I'm just assuming I'm trying to avoid it if I can help it. So notice I have my zeros here. I have the top of a hill here. I have the top of a shorter hill here, but still that's a relative max. There's a relative min here, didn't say anything about that. And notice we have 1, 2, 3 maxes and mins, and that's the maximum we can have if it's a 4-degree function. We cannot have more hills or valleys than that if it's 4 degrees. All right, so you might want to pause here and finish this up if you're not done with that. You also might want to pause here and copy down example 3 from the blank notes and then get ready for that. All right, now moving on to example 3, we need an even degree function. So we know it has to either be both up or both down at the ends, with zeros at -3, -1, 0, and 3, a lot of zeros, and a positive leading coefficient. So that means that the number in front of the highest exponent term is going to be a positive number. So I'm going to make my graph space. Looks like the outlet's almost part of the graph. Okay. All right, so now I'm going to put my zeros at -3, -1, 0, and 3. Because it has a positive leading coefficient, I heard this great thought, which is it means it needs to end pointing upwards on the right side, which means also on the left side, I know it needs to end facing upwards as well. Let's see if I can connect it doing that. So I come down here, go back up, go back down, come back up. Oh yeah. So there we go. Okay, since it's a positive leading coefficient, basically they're going to both be pointing upwards, because when you plug in a positive number to an even exponent, is going to be positive, times it positive is going to make it go upwards. When you plug in a negative number to an even exponent, that'll be positive, times the positive coefficient, which will make that one go upwards as well. And there you go, it's just a quick sketch, it's not perfect. All right, that's how these 3 work. All right, so you're going to stop now and you're going to go back to your quizzes and continue on.